So this is part 2 in our series on area and volume. Make sure to watch part 1 before you start this video. So one of the final types of problems that you can have, and perhaps one that students find the most difficult, is what I call a transforming shape problem. And I'm going to give you 2 examples here. So the first one, we have a golf ball that's been thrown into a cup of water, and the question is, when the golf ball is put into the water, how much does the level of water rise by? So the first thing I do when I faced with this type of problem is I try to draw in to the diagram what's being described. So I'm going to draw in the ball and the rise in the level of water. So we have the ball in the water, and it causes the water to rise that little bit. So we call the rise in the level of water h. So the question is asking us to find the rise in the level of water. That means we need to find the value of h. So whenever you're asked to find the value of a variable, you always solve that by doing an equation. So what you want to look for is something in this scenario that's equal, that involves the letter h. Now, if you know your physics, you know that if you put an object into water, it causes the water to rise by an equal volume. So you could say that the volume of the ball here is the same as the volume of this water here that has risen. And we're already told in the question what the volume of the ball is. It's 10.66 pi cm cubed. So we can therefore say that the volume of this, what is a cylinder shape, this risen water here, the volume of that is going to be equal to 10.66 pi cm cubed, because that has to be equal to the volume of the ball. And whenever you hear the words same as or equal to, you should be thinking straight away, I can make an equation out of these facts. So you can say that the volume of the ball must be equal to the volume of the cylinder shape here. The cylinder shape of the water, that would be pi r squared h. So we can make this equation. We can say that 10.66 pi must be equal to pi r squared h. And the reason I call this a transforming shape problem is that effectively the shape of the ball, which is a sphere, is being transformed into the shape of a cylinder. So now that we have the equation, we can simply input the values that we know from this formula. So we know the radius of the cylinder is going to be half of 10 centimeters, which is 5 centimeters. So we can plug in 5 in for r in this equation. Now if you notice, there's a pi here and a pi here. Whenever you have that situation where you have the same term on both sides of an equation, you can just cancel them out. So we're going to cancel the pi's, and we end up with 10.66 equals 25h. Then to find out what h is, we simply bring the 25, which is multiplying by h here, we bring it over here and divide it into 10.66. So h will end up being equal to 10.66 divided by 25, which gives us 0.4264. So the next question is the question that we saw at the start of the video. And if you remember, in that question it said that there was a rainfall of 5 millimeters during the course of a week on a roof of length 50 meters and of width 40 meters. And the question was simply find out the volume of rain that had fallen during that week. So to get the volume, we have to imagine the rain as a rectangular box shape, where the length of the box would be 50 according to the length of the roof, and the width of the roof 40, and then the height would be, instead of 5 millimeters, we want to make it into meters. So we change it to 0.005 meters, in other words 5 millimeters divided by 1,000. We then take these 3 dimensions, the length, the width and the height, and multiply them by each other to get the volume of this cuboid shape. And the answer that you're going to get for this, I won't go through this now, but the answer that you get for this is 10 meter cubed. We're then told in the question that all of this water gets drained away into a tank of diameter 7 meters. And the question is, how much does the level of water rise in the tank in that week? So again, what I do is I try and draw this out. Just what's being described in the question is that the water goes into the tank, and the question is looking for the rise in the level of water. So we can see clearly what we need to do here. And we also know that the water that was on the roof, 10 meter cubed, is going to be the same as the volume of the water in the tank at the end of the week. So this here is 10 meter cubed. Again, we can make an equation out of this. We know that 10 meter cubed has to be equal to the volume formula for this shape, which is again a cylinder shape. So in other words, pi r squared h. So we can make the equation 10 equals to pi r squared h. And if we look at the diagram, we know that the diameter is 7 meters, so the radius must be 3.5. So if we key in the pi times 3.5 squared into our calculator, we get 38.484. And then we can take this 38.484, which is multiplying by h, and bring it across the equation, the equal to sign, and divide it into 10. You can key this into your calculator and work out what this gives you, but don't forget to put in the unit of measurement, and the unit of measurement is just going to be meters because we're talking about the height. Okay, so the final question that we're going to talk about is rate of flow type questions. Here's a typical example. Then the question says water flows at a rate of 35 centimeters per second into a tank. In other words, a section of length 35 centimeters of water flows into the tank every second. And the question goes on to say, what will be the rise in the level of water after 5 minutes of water flowing into the tank? Okay, so the first thing I do with a question like this is I try and draw onto the diagram what's being described. So water is flowing into the tank. So let's draw in the water. So it's going to rise to a certain level, and we call that level H. And this is actually what we want to find out. What is the rise in the level of water? So what we want to do here is divide this kind of question into two parts. The first part is finding out how much water flows through the pipe into the tank. Once we know that, we can set that value equal to the volume formula for a cuboid shape, because that's the shape of the water here. It's in the shape of a cuboid. So we can put the volume that we get for the water equal to the volume formula for a cuboid. And that's going to help us find out what H is. But let's concentrate in the first part, getting the actual volume of the water. Now the key to doing this is to finding the volume of the section of water here that passes through in 1 second. You have to realize that this is a cylinder shape, and we're told the radius is 2 centimeters and the length, which is really the height of the cylinder, is 35 centimeters. So we need to first of all get that volume, use the volume formula for a cylinder, pi r squared h. So one section is equal to pi r squared h, and simply fill in the values for r and h. So the radius is 2 and the height is 35. If we multiply them out, we get 140 pi cm cubed. So that's how much water passes through in 1 second. Of course, we want to find out how much passes through in 5 minutes. So the first job is to go from 1 second to 1 minute. So 60 seconds in a minute. So we multiply this by 60 to get 60 seconds or 1 minute. But if we multiply this side by 60, we have to balance things out by multiplying this side by 60. So 140 pi times 60 gives us 8,400 pi. So in 1 minute, 8,400 pi cm cubed of water flows through the pipe. But we want to get 5 minutes, so we're going to multiply everything by 5. So 5 minutes equals 8,400 pi times 5, which gives you 42,000 pi cm cubed. So we can write this value now in for the water here, because that's the water that flows through the pipe and consequently ends up in the tank. Now I'm assuming here that there was no water in the tank before the water started flowing in. So after 5 minutes we should have 42,000 pi cm cubed of water in the tank. So as we mentioned before, this water is in the shape of a cuboid, so we can get the volume of a cuboid by multiplying the length by the width by the height. So we can say h times 100 times 200 must be equal to 42,000 pi. And if we multiply 100 by 200, we get 20,000 h. And then to find h, we simply bring the 20,000, which is multiplying by h here, we bring it over the other side here and divide it into 42,000 pi. And if we key this into our calculator, you'll see that we get 6.597 centimeters. So this is the rise in the level of water. That's what the question asks for. And if you think about it, this problem is really just the same as the previous problems I showed you from the previous section on transforming shapes. In other words, the shape of the water here is a cylinder, and it transforms into the shape of a cuboid. So from there we can make the equation and find out the value of the missing variable h. So this is a very special type of shape you might see in some questions on the exam. They're called uniform cross sections, and all of these are examples of uniform cross sections. Now, how can you recognize a uniform cross section? Well, the cross section applies to this part here, so this would be your cross section, and then along the length of the object, all the lines would be parallel to each other, and in other words, there'd be no widening of the lines or no narrowing of the lines. It'd just be a uniform object. So you can see they all conform to this pattern. You have a cross section here, and then all these lines are parallel to each other. They're not widening or narrowing. So the good thing about uniform cross sections is it's very easy to work out their volume. You do that simply by calculating, first of all, the area of the cross section, and then multiply your answer by the length of the object. So for example, in this question we have a right angle triangle, so the area would be the area of a triangle, which is half the base by the height. So half of 8 is 4, so 4 times 3 is 12. The area of this is 12 meters squared. If you want to get the volume of the whole object, just simply multiply 12 by 7 and you get 84 meter cubed. So if we look at this object here, again we work out what the area of the cross section is, and this is a shape made up of a rectangle and a triangle. So I draw a line down the middle here. So from that we can kind of work out what the length of this would be. It would be 2 feet, because this is 3 feet. Take that from 5 feet, you get 2 feet. And this, of course, would be 4 feet, because the same as the length of this. So again, you can work out the area of this triangle using half the base by the height. I'm not going to do that now, but you know what to do. Likewise, for this rectangle, the area of rectangle is the length by the width. So you multiply them out to get the area of this. Add the two together and you get the total area of this cross section. And then to get the volume of the object, you just multiply your answer by 7. So again, this is a uniform cross section, so we can get the area of the two rectangles here. So this one will be 7 by 2, and this one here would be 2 by 5. Remember, this is 5, so this must be 5 as well. So multiply them out, you get the areas of the two rectangles, add them together, you've got the area of the cross section, and then multiply your answer by 2 to get the volume of the object. Now you could also work this out by just trying to get the volume of each separate cuboid here. So there's more than one way of doing these problems. Now this object here, again you get the area of this cross section. So that's made up of a rectangle and a semicircle. So the rectangle is easy, you just multiply 3 by 5, you get 15 cm squared. And then to get the area of the semicircle, you want the area of a circle formula divided by 2, so pi r squared divided by 2, and r would be half of 5, which would, because 5 would be the diameter here, so that would be 2.5. So r is 2.5. Plug that into the formula for the area of a semicircle, add the two, the semicircle and the rectangle together, and then multiply your answer by 20 to get the total volume. So this object here, again, we can do it in the same way. We can get the area of the semicircle here taking the radius as being 5, half of 10, and then work that out and then multiply our answer by 15 to get the total volume of this object. Now you could also view this as being half of a cylinder, so the formula for a cylinder is pi r squared h. So all you'd have to do is divide that by 2, fill in the values, h would be 15 and r would be 5, and you could work out the volume that way as well. Here we've got a cylinder, and we know that pi r squared h is the volume formula for a cylinder. We can kind of figure out where that comes from now, because the circle here would be pi r squared, the cross section, and then you multiply that by the length h, which gives you the volume of the object. This one here is a bit like this one, so you've got a cross section of a triangle, so you'd probably be given the perpendicular height here, or maybe you might be able to figure it out using maybe Pythagoras' theorem or something like that. But once you have the perpendicular height and the base, then you just use the same formula, half the base by the height to get the area of this, and then multiply your answer by the length to get the volume of this. This last one here, again, is just kind of two rectangles, this rectangle and this rectangle. Get the area of those two rectangles, add them together, and then multiply by the length of the object. Now you may also be asked to find the total surface area of some of these objects. I'm not going to deal with that in this video. You'd have to use nets to be able to do that. So that's the one part of the area and volume course I'm not covering here, so make sure to cover that in your textbooks. So as I promised at the start of this video, there are certain formulas that you're expected to know, or at least be able to figure out. So we've talked about a lot of these already, but I tried to get them all together on one page here. So these are the formulas that you have to be able to work out. The most obvious one here is the rectangle, right? You're expected to know that the area of rectangle is the length by the width. You're not going to see that formula. And also, of course, the perimeter is twice the length plus twice the width. Again, that's not going to be in the log tables. Now, next thing we can look at here is the cuboid. Again, you're expected to know the volume formula for this. It's length by width by height. And also the surface area formula, which is 2 times the length by the height plus 2 times the length by the width plus 2 times the height by the width. Now I generally don't learn that off. I can work it out using nets. I'm not going to cover nets in this video. You should cover that in your book if you want to totally cover area and volume properly. But it's pretty easy to do. There's going to be 2 of each side, so that's how you come up with this formula here. Then we have these shapes here. We've just talked about these. They're uniform cross sections. So you just get the area of the cross section times the length for the volume. Likewise with this. And you can use nets to find out the total surface area. Again, not going to cover that right now. This one here, the volume of or if you wanted to get the total surface area of a cylinder, as we said before, you're only given the curved surface area in the log tables, which would be 2 pi r h. So you'd have to add on the base and the top of the cylinder to get the total surface area. Likewise with a solid hemisphere like this one, if you want to get the total surface area, you have to add the curved surface area to the surface area of the top here, which is a circle, of course, pi r squared. And you also won't find this in your log tables. You're going to have to get it from the formula for a sphere, the surface area formula for a sphere, which is 4 pi r squared. So you just divide that by 2 to get 2 pi r squared. And likewise, if you want to get the volume of a solid hemisphere, you take the volume formula for a sphere, which is 4/3 pi r cubed, and you divide that by 2 or multiply it by a half to get the volume for a solid hemisphere, 2/3 pi r cubed. And finally, for a cone, again you can get the curved surface area pi r l from your log tables, and the base is pi r squared. Now, one other thing you might need to know about cones is that sometimes you might get a question like this, where they draw a line down the middle here and one here, and you're told that basically the height is 70 and the radius, well, you can work the radius out from this if if the diameter is 54, then the radius would be 27. So just write that in. And the question might be find L. So find the slant height of the cone. So what L refers to is this line here. And you just got to recognize that this is a right angle triangle. And anytime you see a right angle triangle in an exam question, you should straight away be thinking about trigonometry. And we can actually use Pythagoras' theorem to find out what the length of L is. L squared is equal to 70 squared plus 27 squared. You solve that equation to find out what L is. So if you like this video, check out my other website, www.danswers.ie. On that, I have lots more videos like this, including videos to some of the most difficult exam questions on the Junior Cert. Check that out, and you might also would like to subscribe to this YouTube channel because I will be uploading more videos in due course.